Hi, everybody. So, MIT just released a paper yesterday, June 15th. On the paper's title is called Exploring the MIT Mathematics and EECS Curriculum Using Large Language Models. And the entire research was put out by actually multiple universities. So, in partnership with MIT, you also have Stanford, Harvard, Cornell, multiple leading Boston University, multiple leading Stanford, and multiple leading institutions with regards towards this study and what it says. And then so the abstract of the study is essentially that they created and curated a data set of 4,550 questions related to mathematics and engineering and everything involving the subject. And so they, for purposes of making sure that the data set stays clean, they're not releasing the full data set. But if researchers are interested, if you happen to be a large researcher and you're interested in this particular data set, you can contact the MIT team directly and get access to their full data set. But the data set itself isn't the most interesting part of all of this. What is the most interesting part of this MIT paper and what we're looking at and why we're discussing it is that they introduce and they prove throughout this paper that large language models can utilize and learn through prompt engineering, and they can essentially teach themselves through prompt engineering. And this particular study that they release is a very interesting study. So as a baseline, they created and they curated this set of 4,550 questions. And then they ran multiple models, GPT-4, GPT 3.5, Stable Vicuna, and Llama through the tests, and then they benchmarked essentially the tests. And then if you see here, it's on all different types of subjects. So starting off with like algebra, calculus, topology, across the board, theory of computation, anything that's related to electrical circuits. So like anything that's mathematics or engineering related very specifically is what this data set entails. And they also give it levels, and then they tell you exactly how many questions were involved here. And then if we scroll down, what we can see is these are just breaking down some individual results. And then these are also laying out there essentially how they went about optimizing the results afterwards, which we'll talk about more in depth. And then this is going through the methods that they use to optimize the prompts, which we can come back up to here. But what I want to show is results broken out by model that they have, which I think is a graph. It's a little bit, here we go. And then so this particular graph I think is very interesting within the paper, as it's showing essentially the benchmark results for their tests. And I think there's multiple things that are interesting about this. So the very first thing is that the baseline GPT-4 scored 90%. And so I think that's important to highlight, that like, so their baseline before doing any other training on the model was already 90%, which was already smoking all of the other models. So I think that's one important thing to highlight, that like, for example, the other models that it's going against as far as just baseline training are the Llama 65B, Llama 30B, fine-tuned model, and Llama 30B, and then Stable Vicuna. And then so a few things here. You can see a difference here, a major difference here between the fine-tuned model and the 30B model. What's that, like almost like 12% difference just between fine-tuning the same exact model. So what this means for anyone that's like kind of just ancillarily curious into the subject is taking the exact same LLM model, but just training it more and giving it more fine-tuning, meaning adjusting the weights, and then also giving it more data related to the subjects. And then so just by doing those two things, and that difference essentially counts for the 12% there in the models. And then the other thing that I want to highlight within this very specifically is that, so the Llama 65B, the numbers are the number of parameters within the model. So the higher the number of parameters in the model. And then so you can see here that Llama 65B, which is 65 billion parameters on a base level, is beating Llama 30B, which would be expected, by about 4 percentage points. So you can see that as you scale up higher, that you do run into limitations just through pure scaling, and that fine tuning here can actually give you much better results than scaling up. So rather than going from 30 billion to 65 billion and then getting that 4% improvement, if you take that same 30 billion model and then you fine tune it, you can get 12% increase. But then the other thing to highlight here, and I think is one of the most important things to highlight within this, is that looking at the difference between even the llama models and the high-end llama models and the high-parameter llama models compared to the Vicuna 13 billion model, parameter model, which is beating all of the other llama-based models pretty significantly. And even the fine-tuned MIT model, if you just take the base Vicuna 13 billion parameter model, it's beating the $30 billion parameter fine-tuned MIT model. So again, just showing and highlighting that size doesn't matter, and then the optimizations that you're making otherwise to the models, we can see it matters a lot more in these things. And that's kind of overall what this paper is describing and going over, within going back up to essentially the methodologies and what the heuristics are that they're using for this paper, essentially breaking down the methods that they use. And these are so going through the heuristics that they lay out here. These are all pretty standard things that I see a lot of people talk about. And when they talk about prompt engineering, so zero-shot learning, few-shot learning, chain of thoughts, tree of thought, an example, essentially following these different models and then training your prompts off of this. A lot of people that are talking about AI overall, they highlight these things when it comes to prompt engineering. But with this MIT study very specifically, I think it's interesting because it's, again, taking that to the next level and showing that not only is this successful for prompt engineering and output and a desired output from the LLM model that you want, but that prompt engineering in this way can also be utilized to literally train the model itself. So essentially, by telling the model and instructing the model that it's an expert, basically, that's kind of, if you break down at an essence what this study lays out, it's an interesting conclusion in that it's saying that by essentially telling the model that it's an expert in a subject, it enhances its expertise overall on the subject. And then going back down to this graph, the parts that we didn't go over before were the GPT-4 benchmarks. And then so again, you can see that just right off of the bat, it scored 90%. And then, but when they introduced the different layers of the training that the MIT study is laying out here, so the first one being few shot, and then adding different elements of it, such as self-critiquing plus experts plus chain of thought. If you combine every single one of those elements, they were combining essentially the four different elements on top, they were able to get GPT-4 to get a perfect score, literally perfect score out of the 4,550 questions that they have listed within their model, and were able to essentially improve 10% from a baseline of 90% and get it to accurately improve its results significantly only through prompt engineering. And then so if you go through, the big part of this is that they don't want to release the actual data sets that they utilize for very specific purposes, because they don't want any other AI model to be trained on the data, which would happen if they released it. So I completely understand. This is just going over more as to the types of questions that they outline. But the very last thing that they give is very specific, like meta example of a question that they use, as well as how they prompt engineer it and get it to get the model, GPT-4 in this instance, to be able to enhance its answer. And then this is on a question that it had previously gotten wrong without prompt engineering, and then by utilizing prompt engineering and giving it this additional elements and additional information as to what it should look towards or how it should solve the problem, it was able to solve the problem that it was previously unable to solve only through prompt engineering. So again, I think that that is the significant breakthrough within this paper. And so more and more, it's overall clear that AI models do employ, and machine learning is just that, machine learning on some instance and on some level. And there are kind of unique ways within that in which you are able to train a model to learn. And so there could be and are broader implications within that, but what exactly those are, I think we are learning more and more as we go about. But to me, I think overall it's a more clear picture overall in general that these models are capable of what we would classically define as learning on every single level, and by adopting that and going along with those approaches, every single paper that we see, and this paper in general backed up by essentially every single Ivy League and ancillary institution within the United States, is backing up these results that these models are capable of learning via processes that would be typically classified as thought processes, but again in very unique and interesting ways. Like, it's a very unique concept that you can tell a model to essentially become an expert on a subject, and then just by simply doing that, by encouraging the model in this instance, it's able to improve those results, which is again in line with, if you think about it in an overall context, in line with a lot of things that we know about learning overall. I think the only shocking conclusion there to me is that the fact that this does actually apply to machines that learn. And I think again we are drawing that conclusion more and more, and so I think that's a big takeaway from this paper overall. So again, if you want to check out the paper, I'll leave a link in the description below, but it's exploring the MIT mathematics and EECS curriculum using large language models. If you like this type of content, please like and subscribe. Thank you very much.